Good morning, everyone. Welcome to our Snack and Learn webinar on recommended practices for lighting aviation terminals. My name is Russell Gettle. I'm a lighting designer with WSP. I've worked here in the Boston office for coming up on 12 years. We have a team of about 10 folks here that do various types of transportation lighting, including aviation, which we're going to talk about today. Go ahead and get started. So today we're going to talk about, just to give you a quick idea of what we're going to go through, we'll talk about some of the lighting requirements we consider when we design aviation terminals. We'll talk a little bit about the lighting language or terminology we use. I know that some of that might not be familiar to a lot of folks. We'll talk about the layers of lighting that we can use when we're designing these spaces. And then we'll walk through some of the general areas that we include and some of the areas, the focus areas that we can work on. We'll also talk about wayfinding, which is an increasing part of what we work on and when designing these projects, and daylighting, which is another important consideration. We do want to talk a little bit about controls. Again, they're becoming a more important part of what we do. And then lastly, I'll talk a little bit about the IES Transportation Facilities Lighting Committee, which is working to spread these best practices for everybody that does this kind of work. So often on lighting design projects like these, we'll start with the energy code. These are the requirements that we have to start with. For us, we're worried about the lighting power density or watts per square foot of the installed lighting. I'm not going to talk a lot about emergency or egress lighting, but it is part of what we do. And lead and well building requirements are becoming a larger part of what we do as well. And then beyond those requirements, the IES, or Illuminating Engineering Society, has a series of RPs, or recommended practices. And like I said, we'll talk about that a little bit more at the end. Some of the terminology that the lighting designers use. We talk about lumens as being the amount of light emitted by a fixture or luminaire. We talk about the distribution, where that lighting is going. We'll talk quite a bit about that today, I think. We talk about luminance, which is light reflected off a surface, and that's what we see. That's what our eyes pick up, is the light that's actually reflected off a surface and hitting your eye. And often in these recommendations, we talk about illuminance, which is we're measuring the light falling on a surface. It's a little easier to measure than luminance. And we talk about that as either horizontal illuminance, which should be on a surface like a desk, or vertical illuminance, which might be a wall or a sign. And then we also talk about the efficacy of a light fixture or luminaire, which is in terms of lumens, light emitted, per watt of power consumed. A couple more I want to spend a little more time on is the CRI, or Color Rendering Index. On the graphic, you can see a bunch of different spectral power distributions for different light sources. And what CRI attempts to do is to simplify this down to a metric, 1 to 100, of how well standard colors appear under these different light sources. Because depending on which wavelengths of light your light source is emitting, you can actually change the color of what you see. So CRI is a simplified and kind of imperfect metric, but it gives you a quick glance of how well colors are rendered under that source. Another important metric is correlated color temperature, or CCT. These are all for colors of white light. As I'm sure most people have experienced, white light can appear cooler or warmer. For electric lighting, we do use a color temperature of between 27, usually about 2700 Kelvin, up to around 4000 Kelvin. So these are the kind of common temperatures. Frequently, we'll use something right in the middle, which is around 3500 Kelvin. Now we'll talk a little bit more about the layers of lighting we include when we're designing a facility. These are a couple pictures from the San Diego airport rental car facility that I worked on a few years ago. And we'll talk about the functional lighting. This is on the left is the drop-off canopy, where we have a downlight to highlight the floor where people will be stepping off the buses and heading into the rental car counters. In addition to that kind of functional lighting on the floor, to avoid this canopy feeling like a cave, we've also included some uplight on the canopy itself and some wall washing, some downlights at the back, which highlight the rear wall and the signage. On the right, part of this project was even more decorative lighting for the back of the facility, which is actually the public side, the street side, which faces the Pacific Coast Highway, where we did some wall washing to highlight the building and give it kind of a public face that the community can see. I talked a little bit about vertical luminance, some of the wall washing in the previous picture. Here's another application. These are the restrooms at the Baltimore Washington Airport Terminal A expansion we did a couple years ago. In the bathroom here, we're providing some downlight at the mirrors, but also we had the fixtures wrapped down the wall to provide some vertical illumination. So here we're lighting people's faces so they can see themselves in the mirror. We also have in the background, there's a dedicated mirror with lighting built into the glass itself all the way around. So when people are looking in the mirror, they can see their face. They won't have a strong shadow from above from the ceiling lighting. Now we'll talk a little bit about some of the general areas, terminal areas. This is also BWI Terminal A. And in the hold rooms, seating areas, we use a grid of 2x2 fixtures, nothing too fancy, but they provide a good ambient light across the whole area for folks that are sitting down and reading. And then in the circulation areas in the center of the terminal, we have a taller ceiling, and we're able to emphasize the height of that space with a little bit of uplighting and provide a little bit of a different quality of light for the folks as they're navigating the space, looking for signage, looking for their gates. And I did want to talk a little bit about uniformity, which is one of the metrics we use. And in the seating areas, uniformity is important. We want a fairly even lighting so that no matter where you're sitting, you're able to read, you're able to see the gate. But then in some of the other focus areas we'll talk about in a moment, that's a little less important. We talk about task lighting. This is the Terminal E connector at Logan Airport. Here we provided some table lamps for folks who are sitting at the work area with either their laptop or their newspaper. We also, along the windows, in this photo was taken during the day, so there's a lot of natural light coming in. But we also have some pendants over by the windows for those tables for folks that are sitting there, in addition to the general ambient lighting. Another big thing we work on is wayfinding. Wayfinding is really important at airports. Folks are traveling, they're not familiar with every individual airport. We do signage is a big part of that. We also do internally illuminated signage. And then sometimes we get to do something fun like this. This is the Bradley Airport in Connecticut. This is the main elevator. previously their elevator was buried kind of back in the behind the check-in counters, and it was hard to find. So working with the airport, we moved it out to this very prominent location right outside the TSA entrance and exit, so that when you come out from the airport, it'll be the first thing you see. And they let us do some fun work here with some color changing lighting. Typically this is actually blue, but they can also change the color for special events, holidays. So this photo we're showing kind of a pink. And then on the lower floor, this is the blue color that they typically use. And I wanted to highlight here the information desk. We can use different levels of lighting to draw your attention, not only the color change of the elevator, but also this information desk, which is brighter than the ambient surrounding baggage claim area. So, you know, we can use our lighting design to draw attention to and direct people to where they need to go, either to the elevator, the information desk, and so on. Similarly, this is the C2B connector over at Logan Airport. We do have some rows of downlights here. At the gates, though, we use these decorative pendants to show everybody visually where the gate is. So as you're walking by, you'll see the signage, you'll see the pendants hanging down from the ceiling, giving you, again, pointing out that this area is different. This is where you should be looking. This is where you should be going. And I wanted to talk a little bit more about that as far as placemaking. A couple more photos from the C2B connector. For some of the more casual seating areas, we worked with our architecture partners to have this perforated metal screen, and then added instead, in place of the regular downlighting, some of these pendants to highlight the seating area. On the right is what they call the Composer's Lounge. Again, this is a small seating area carved out to the side with some posters, pictures of composers from the Boston area, Boston Pops. And in this area, we do have some downlighting, but we also added wall washing and sconces to highlight that area, to set it apart, do something special there. One of the big things we spend a lot of time working on in airport terminals is daylighting. We like to have daylighting included. Everybody likes to be able to see outside. We also, at the same time, need to control the amount of daylighting that's coming in. The picture on the left is the BWI Terminal A expansion. We have some clerestory windows up top, which are bringing in daylighting into the central circulation. We have some skylights that go across, and they do a good job of bringing in daylighting while preventing glare. The shape of the skylight is designed to bring in the light while cutting off the kind of direct view of the sun. On the right is a solar study we did very early on in the design of the C2B connector. We looked at a couple of different design options, an overhang, a light shelf, and some electrochromic glass. And we looked at it at a variety of different times of day as the sun moves across, and different times of year, because of course in the summer, as opposed to the winter, the sun is higher in the sky, the angle will be a little bit different. You can see that this particular location faces southeast. So in the morning, especially in the summer, it got quite a bit of daylight, gets a lot less in the afternoon and evening. We eventually went with the electrochromic glass, which is part of the control system, which we'll talk about next, dims to limit the amount of daylight coming into the space so that it doesn't become uncomfortable. This is a photo of the C2B connector. You can see some of the controls, daylight controls up on the ceiling that are watching and measuring how much daylight is coming in, and then dimming the electric lighting up or down depending on the external conditions. And as part of that, the electrochromic glass in the facade is also dimming depending on how much lighting is hitting that. Controls are a bigger and bigger part of what we do, beyond just the lighting design, but also making sure that the control systems are coordinated, working together, and working correctly. Commissioning is a big part of that, and a bigger part of what we do as a result. Now I want to talk a little bit about the IES Transportation Facilities Lighting Committee. I'm the vice chair of the committee. It is more than just aviation. We're talking about trains and buses too. But for aviation, this recommended practice would cover areas that are not covered by some existing RPs, which RP8, which is roadway lighting, including garages, and RP37, which is airfield lighting. So we've identified this kind of gap between those two existing RPs that we're going to try and fill in. We're on schedule. We're writing it now. We're on schedule to publish next year. It'll go into review later this year. We don't have an RP number for it yet, but like I said, we're still working on it, and new contributors are always welcome. If there are any folks on the call who are interested, please reach out. You're welcome to join us. And then I will say thank you for everybody for listening, and turn it over for questions if we have any questions coming in. Okay, first couple questions coming in look like, what is the best time to bring a lighting designer onto a project? So we've started at various points on various different projects. I think especially if we're brought in early, we can participate in and collaborate with our architecture partners, doing some of the solar studies like I showed earlier, and that we can really make a positive impact if we're involved that early. If we're involved later, then we're limited a little bit into what we can do to basically just providing the best electric lighting we can. Another question coming in, what about light pollution and dark sky concerns? So we do exterior lighting design as well. When we're doing exterior lighting design, we do try to limit to full cutoff fixtures, which emit no light directly upward. Similarly, for interior lighting, we are trying to prevent stray light going up. We want light to go down onto people's faces, vertical illuminance, like I talked about earlier, or horizontal illuminance onto the working surfaces. And then again, that's following the best practices, trying to control the lighting and putting where it's needed. All right, another question. Will I share the presentation? I was not planning on sharing the presentation. However, these are all WSP photos. If there are folks working on a pursuit, you can reach out to me and I'll be happy to work with you to use these photos in any of the promotional material. Let's see, are there any other questions? Question coming in. I saw a display in that information kiosk. How do displays factor into your lighting studies? That's an excellent question. That is one of the coordination items we look at. We do try to avoid kind of, if a display or sign is internally illuminated, we do try to avoid external illumination on that sign that would either provide a glare, reflection in the signage, or that would kind of wash out the sign itself. So we try to coordinate the location and distribution of the fixtures so that we can avoid those signs. Any other questions? Would you say 3000 Kelvin and below lighting affects the safety of, per se, a parking lot? So there are some subtle differences between the color temperatures. Um, the 4000K, the higher color temperatures do give a small advantage to visual acuity in an exterior environment. So at night in a parking lot, we do generally use 4000K. For interior spaces like the terminals we're talking about today, we usually use a warmer color temperature. Part of that is cultural. Americans and a Western audience prefer a warmer color temperature, usually, that is similar to the incandescent lighting we all grew up with. Other countries, I know the 4000K is more common inside. A classic example, I guess, is Japan, where 4000Ks and sometimes even cooler temperatures are preferred. Um, all right, well, if there are no other questions coming in, um, I will turn it back over to you and let everybody get on with their day. It's a beautiful spring day here in Boston. I hope everyone has a good day. Thank you.